Okay, so today we're going to start 12.4 volumes of prisms and cylinders. From here on out, we're going to focus on volume, which in my opinion is a little bit easier. The volume of a solid is the number of cubic units contained in its interior. So whenever we're thinking volume, we're thinking what's inside versus surface area is what is on the outside. So here we have a cubic unit. Okay, so think of just a cube, and we're thinking how many of those can we put inside of this box, right? So we have 1, 2, 3, 4, 5 that direction, 3 this direction. So kind of imagine in this first layer, there would be 15, right, square units. And then we have the height. And if you notice here, we have 1, 2, 3, 4 units high, so 15 units each stacked with 4 layers. So that would be 60 cubic units. Okay. Volume of a prism. Okay, if a prism has a volume of V cubic units, height of H, okay, so we have a height, and area of the base, we're still going to use that capital letter B to represent area of the base. We can do the volume is base times height. Now, if we have something like that previous example where it's just a box, it's very easy to find the volume. You simply take the length times the width times the height, or just multiply the 3 measurements all together, and you'll get the desired result. Now, if it doesn't look like a box, you're really going to have to focus on what is the base, right? Find the area of that base. What is the height, right? And then multiply it together. Okay, so in this case, again, in a prism, you have to have 2 congruent bases that are parallel to each other, which means this is our base. That right triangle is our base. So if I have, this is 8 and this is 17, I have to figure out what A is. So I'll have A squared plus 8 squared equals 17 squared. So 17 squared minus 8 squared is going to be 225. So take the square root of that and we get 15. Okay, so the area of the base, it's a triangle, so we're going to do base times height divided by 2. Keep in mind that's the height of the triangle, not the height of the whole prism. So that will be 60. So area of the base will be 60. And again, the height is always going to represent the distance between the 2 bases. So in that case, it's 13 for the height. So for volume, we're going to have area of the base times the height. So our volume in this case is going to be 780, and it's cubic centimeters. Okay, next one, it is a cube, which is actually super easy. We can just multiply, right? We'll multiply 8 times 8 times 8, or 8 to the 3rd power, and we get the volume is 512 cubic feet. Okay, C. So in this case, our base is going to be this trapezoid here, because we have another one, right, congruent and parallel in the back. So, and then we can identify 6 centimeters, that's the height, because it's the distance between the 2 bases. So for this one, since it's a trapezoid, all right, we're going to take the height, which is 1.5, and then in parentheses we have base 1, 2, plus base 2, which is 4, and we're going to divide by 2. So we'll get 6, 3 times 1.5, and we get the area of the base is 4.5. So our volume, area of the base, times the height, we get the volume is 27, and we have centimeters, so it's cubic centimeters. Okay, next we have volume of a cylinder. Volume of a cylinder is exactly the same thing as volume of a prism, it's really area of the base times the height. Of course, in a cylinder, we always have a circular base, so we could just remember that it's pi r squared times the height. Again, the height is always going to represent that distance between the two bases, which are circles. Okay, find the volume of each cylinder, round to the nearest hundredth place. Okay, so my volume is area of the base, which is pi r squared, so pi times 3 squared times the height, which we see is 8. So if I were writing this in exact form, this would be 72 pi, but rounding it to the nearest hundredth is going to be 226 point, and it's 195, so that'll be 20 cubic centimeters. In part B, they give us this diagonal piece here, so we're going to have to figure out the height by doing Pythagorean theorem. Right, here's our right triangle. So I have 10 squared plus h squared equals 16 squared. So I'll take 16 squared minus 100, so h squared is 156. So I'll just leave it at square root of 156 for the height. And then for the volume, we're going to do pi. All the way across was 10, so that makes the radius 5. So 5 squared times the square root of 156. So we'll plug that all in. This time I'll just write it as my approximated answer, so that'll be 980.96, and it's centimeters again, cubic centimeters. Okay, so our last example here, volume of a cylinder is given as 1017.9 cubic meters and the height is 9. Find the length of the diameter. So first thing, we know pi r squared times the height is our formula. So the volume is what I know. And I also know that the height is 9 meters. So if I divide both sides by 9 pi, that will be what I get for r squared. So I'll do 1117.9 divided by 9 pi. Make sure you put 9 pi all in parentheses so you're dividing the whole thing. And I get 36 point, and then it's like 0008. So when I take the square root of that, it's pretty much going to give me r is 6, and the units are meters. And that's the volume of prisms and cylinders.